Hi, and welcome back to our review for the Chem 4 final. In this video we're going to cover pH of strong acids and hopefully get to an example. The first thing you must, and this is vital for all of these pH questions, you must be able to distinguish a strong acid from a weak acid. Now this is our strong acid song. This is how I know my students. They all know this song. Here it goes. HNO3 and HBr. H2SO4, HCl, O2, O4, say hi, strong acids all. HNO3 and HBr, H2SO4, HCl, HClO2, O4, say hi, strong acids all. So here's our example of a pH of a strong acid. First of all, you ask yourself two questions. Is this an acid, a base, or a salt? And since it starts with an H, we know it's an acid. Second question with pH. You're going to ask yourself, is it strong or weak? Since it's in our strong acid song, HCl, we know we can, to figure out the hydrogen ion content, or molarity, we just take the molarity of the acid and multiply by the number of hydrogens in the formula. So the hydrogen ion concentration is our molarity times the number of hydrogens in the formula, which is 1. So our molarity of hydrogen ions for this example is 2.00 m. That's a memorized formula for a strong acid. Now pH for a strong acid is going to simply be equal to minus the log of the hydrogen ion concentration, which is minus, for this example, minus log 2.00. So our pH here is minus 0.31301029997. First, let me make sure you understand that that negative in the formula is not a minus sign. Go to the bottom of your calculator, find the little negative sign in the parentheses. That's the button you're going to push for the negative log. So now our pH has got a whole bunch of numbers. Very important for you to understand that only the numbers after the decimal are significant. So, whenever you're doing significant figures, you go back to the problem, the question. Look at the numbers they give you. 2.00. Since it's a number with a decimal, you start on the last number, whether it's a 0 or a number. You keep counting till you get to the last non-zero number. So we have 1, 2, 3 significant figures. So what does that do to our answer? Well, all the numbers are after the decimal. I'm going to underline our 3 significant figures. Since the number after the last significant figure is not 5 or greater, this number 1 here stays the same. So our answer for this pH question of a strong acid, minus 0.301. Now, for pH of a strong base, you need to look at the periodic table to figure out what is a strong base. And I use the phrase Lix Kaba. These are going to be our strong bases. If you look in group 1A on the periodic table, you'll see we go lithium, sodium, potassium, rubidium, cesium. Since all of these group 1A elements have a 1 plus oxidation number, if you simply add an OH, which has a minus 1 charge, you've turned them all into strong bases. Lix. Now look at group 2A. Here we're only going to go from calcium, strontium, barium, Kaba. Since group 2A elements have a 2 plus oxidation number, we have to add 2 OH negatives to balance out the charge. So if I add OH2 to all of these group 2A, now these are all strong bases. Lix Kaba, strong bases. Let's, how are we doing? Good. Now remember, and we'll do an example of a strong base pH in the next one, but when you have a strong base, you need the OH negative concentration, which for a strong base is going to be equal to the molarity of the base times the number of OH groups in the formula. Be careful. You can't get pH from an OH concentration, but you can get POH, and that's going to be negative log of the OH concentration that you get here. That's a memorized formula. Memorize, memorize, memorize. To get pH from POH, remember, you're going to take 14 minus POH. We'll be back in our next video with an example of finding pH of a strong base.